All right, I'm gonna put this in there just to give you a chance to get active in the chat this morning. I'm gonna put this up on the screen. So where you at today? 1 through 5. Everything's Daniel's at a 3. He's right there in the middle. Not a bad place to be. We don't have a sleepy option this morning, so yeah. I'm seeing lots of 2s and 3s up to this point. It's kind of hard to be number one this early in the morning, didn't it? Unless you just had a great dream or something, jumped out of bed all pumped up today. 2s and 3s, that's about right. That's probably about where what is. That number 5 is pretty entertaining, but well, I'm probably about a 3 myself. I can go right along with the class on this. About the right place. Although I did dump my Coke in the car this morning. All right. Well, let's look at our lesson. Let's get things going here. Got enough of that. Foundations of Programming. Starting our last module before the semester ends. We're done with Module 2 now. Let's look at our grade screen as usual. See, our Module 2 project was due last night. So hopefully you've got that turned in. I saw that I have some of them to grade that have been turned in. So if you haven't got that turned in, get on that right away. We got Thanksgiving break, and you don't want to work over Thanksgiving break. You want to get everything turned in. This is our last module. Notice the first semester final exam is on the board now. On the board. So we're getting right down to it. Turtle graphics is what we're going to be looking at this week. And then for loops and while loops and creating functions. And then we've got our final exam. So we have 4 lessons left to get in before we get the end of the year here. And we got the Thanksgiving break coming up after this week. So let's take a look at these turtle graphics it's talking about. Closing module 2. Turtle graphics lesson. We get to play with some graphics. They're very basic here in Python, but we're going to play with it. All right. Oh, let's have an honest conversation about turtles. Interesting. I was over at my daughter's house last night, and my son-in-law's sister was there, and she has turtles that she takes with her everywhere she goes. She had her pet turtle with her. She lives up in Missouri. She brought her turtle. Let's have an honest conversation about turtles. They live to a super old age, and they can sometimes be ninjas, as we've seen on TV and in the movies. And they take the concept of mobile homes to a whole new level, right? They also have made a pretty awesome contribution to the programming world. We're going to see how turtles have influenced visual programming. So we're going to explain the role of Turtle Graphics module, understand how programmers can utilize turtle graphics, and demonstrate understanding turtle graphics by setting up and moving the turtle today. So let's get into that. You've heard of those apps that map out your exercise, right? Maybe you got a Fitbit and other stuff. But these apps, they draw a line that shows the distance and direction you run. Usually on a map, it'll show where you went today when you ran, or maybe you drove. No judgment, because that's probably what I would do. These actually work a lot like a set of functions of Python, like turtle graphics. The turtle graphics would look a lot like your little app would do. It's one of many modules that Python has in its library of functions. So by using this, we're able to import pre-written code. Turtle graphics is a whole bunch of code that's already written. So all you have to do is put in the command, and it'll do what it's supposed to do. So they can use the input function to prompt users to enter information rather than having to write the entire program together input. So these type of things. Turtle functions let you program visually by moving your cursor around the screen. So you can make an imaginary turtle draw pictures using an imaginary pen. So right here off the bat, we've got our first Python code to look at. All right, hashtag the turtle module. So that's just a comment, right? So look, before in the last unit, we had to import the math functions, import the math unit. We have to import turtle if we want to use the turtle graphics. We tell Python, go get the turtle graphics module, bring that into this program. And then we look. So it says read the code, try to predict the output, right? And then we're going to run it. So this says define main. There's our main function as always. And we got Tom. Obviously, that's a variable. of some sort. Tom equals turtle. Okay, interesting. And then it says Tom forward 50. Tom left 90. Tom forward 50. Any idea what that's going to do? So Tom equals the turtle. Forward 50, left 90, forward 50. Well, let's run that and see what it looks like. Oh, it opens up another window for turtle graphics. And look, it drew a line. It turned left and drew another line. Now, have you figured out now what the left 90 meant? What do you think the left 90 was in that code? Looking at what it produced, any thoughts on what left 90 meant? Actually, if you look over here on the little paragraph, it gives you the answer. Although this is wrong. This paragraph is wrong. It turned and went up, as I said. Yeah, basically what it did is it went forward 50 pixels. All right, so it went forward 50 pixels, and then turned left 90 degrees. That's what the 90 was. It turned left 90 degrees, and then it went forward another 50 pixels. Because notice these lines are the same length. So the turtle went to the right, it went forward. So obviously it starts going to the right. That must be the starting position. And then it turned left 90 degrees and went a 50. Now this says it went forward 50 pixels, turned 90 degrees, it went forward 90 pixels. Oh, see, that was wrong. We found a glitch in our lesson. It did not go forward 90. It only went forward 50. So they goofed up. Wonder what else turtle can do. Let's look at the next slide. All right, so the same thing at the top. Import turtle, define main, Tom equals turtle. This says run program. Oh, this says error, name Tom is not defined. Can you see why Tom is not defined this time?
It's a comment.
Yes, it is a comment. They snuck a little comment right there in front of it. If we delete that, now it's exactly like the code we had. Oh, now it says turtle's not defined. Oh, why is turtle not defined now? Let's compare it to the previous code. Tom equals turtle. It says that this is not defined now on line 7. Oh, that's because import turtle also has a comment. Now it can do it. There's a comment there and there was a comment here. There was 2 comments. It did not import the turtle and it didn't define our Tom variable. You can call this whatever you want. They're calling Tom Turkey or Tom Turtle, I guess. All right. Let's look at our slide 3. Import turtle. Okay. No comments. So we're good. No comments here. Now, oh, look here. We got a lot more going on with our Tom right here. So forward 50, left 90, forward 50, left negative 85. Forward 35, left 110, forward 70, left negative 20, forward 20. So obviously it's going to do a lot more turns and a lot more lines of different lengths because this says forward 50, forward 35, forward 70, forward 20. And let's see what this does. Okay. This is how we started last time. 50, turn left 90 degrees, 50. Now it turned left negative 85 degrees. You think there's a better way to, what happens if we just said right 85 degrees instead of left negative? Let's try right. See if that works. And take away the negative. So right 85 degrees. Let's see if it looks exactly the same or did that change anything? Yeah. See, left negative 85 is the same thing as right 85. Just a different way of saying it. It's kind of an odd way to think about it. I want to turn negative left. No, you don't want to turn negative left. Turn right. But it works that same way. How many degrees to turn? If you think about it, this is, using a circle, you can turn up to 360 degrees. So if we said instead of left 90, let's turn left 180, it should go the other direction. It should go backwards. Well, we wouldn't see that. If we say left 270, then it's going to go down, right? Because it turned 270 way down there. So it's just thinking about a circle with 0 being on the x-axis, right? 0 and then 90 around that direction. All right, so positive and negative values can be used. However, you could also do left and right, but it does negative. So let's look at the fourth slide and see what they're doing now. Explore with the turtle by adding our own commands. Where will your turtle go? Okay, so this is exactly what they had. So let's see. Let's add our own. Tom, let's go right 135 degrees. Oh, 35. And then go Tom forward 200. Let's go a long ways. So it's going to do the same thing it did, all that going up. But then I turned right 135 degrees and went off the screen. 200 is too far. Let's make it 100. There's everything it did. And then I went 100. So you can get in here and play. This is a good place for you to get in there and play with that. Now, this is a good time to point out also, because we're not going to go into all of this. In our Google Classroom, if we go back to the top up here where I have all the Python commands, let's open this up and take a look at this. Python commands. When you're playing with the turtle, here it comes. There are a lot of commands that the lesson's not even talking about, because you can go turtle graphics modules at towards the bottom here. So let's go down to turtle graphics. Because when you use the turtle, you may want to get fancier than just turning left and right. Getting close. Turtle graphics. There it is. So constructor details. So it starts at 0, 0, like on a graph, right? Kind of right there in the middle. You can use backwards with a number of steps backwards, number of pixels backwards. Look, you can change the color. Terry.color.red. We were using Tom. You can use whatever you want. Color gold, begin fill, and make a circle. There's all kinds of commands that you can come down here and look at that in Google Classroom if you want to play. See, that made an orange circle and then made a purple circle that was bigger. So it made an orange circle inside a purple circle. So there's all kinds. You just go look at these commands and play with it. This was a radius and arc degrees command. So 40, 270, 25, 1, and play with these things and get like you want. Let's see. There's another fill, begin fill, circle, end fill. So they end the fill at the end. Color red, Terry.color red. So let's look at that real quick while we're playing with that. If we put right in here, Tom.color red, run that program. Oh, look, see, it changed red right there. It did everything above that. And then when it got to this line, we changed the color to red. So yeah, you can play around with different commands that we've got there in our Google Classroom. So you can kind of get ahead and see all the different things. Oh, and here it sets the position. So instead of starting at 0, 0, it moves to 75, 75, and then goes blue. And see, what they did is they picked the pin up, because the turtle starts at 0, 0. So this command picks up the turtle, moves him over to 75, 75, sets him back down, and then paints blue. Oh, pin down right there, pin down. They take him to 75, 75, change it to blue, and put him back down there, and then move. So you could do things like that as well. So like I say, you can play with this. Let's go to the next one, see what else they're going to add to this today. Using turtle graphics. All right, so here's the important stuff you need to know. Using turtle graphics. Number one, you have to import the turtle. Right there in yellow. Import turtle. You got to import the turtle graphics module. So you have to start with that. And then you have to name your turtle. They named it Tom before. Now they're naming it Raphael. Got to name your turtle. So you get to give your turtle a name. I don't remember the name of the turtle that was at our party yesterday. I don't know that I found out. Turtle. So you name your turtle. After you start your main function, name your turtle, and then start moving your turtle. So you import your turtle, you define your main function, you name your turtle, Raphael, and that turtle. And then you tell Raphael what to do. Raphael, go forward 50. Raphael, turn left 90 degrees. Raphael, go forward 50. So that's the basics of how this works. You bring the turtle in, you name it, and then you tell him where to go. And then you end your main function. So the turtle graphics module got a lot of useful functions for drawing. Forward, backward, left, right. Notice the forward function requires an integer parameter. You gotta put an integer in here to tell it how far forward to go. You know, how many pixels. So there's a ton more stuff to do. Oh, is this a link to the same thing, the turtle graphics module? It may be a link to the same thing we have in Google Classroom. Let me click on that and see. Yes, this is the same thing it's in Google Classroom. So they have a link to it right here where you can look at all the different commands that they have in the turtle module. So there's a link to it right there as well. That's another place you can get to that. All right, let's look at page 4. What can turtles do? So can turtles draw more than just lines? You bet. Add more instructions by using the functions from the turtle module that we just looked at. Connect the lines, create shapes, patterns, anything you like. So being able to see a visual image of something you program can be pretty powerful. It's pretty cool. Could lead to some inspiring ideas. I mean, look at Picasso. He started with basic shapes, and the rest is history. Here's our programming spotlight for today. Seymour Papert. It's not Papert. It's like Papert. Most likely to build an army of robot turtles. This co-inventor of the Logo programming language, it's a different language, Logo, was also an early innovator in artificial intelligence. He set the groundwork for what we know as turtle graphics, creating the Logo turtle, a tiny robot turtle that taught children how to program through problem solving. This says he's still alive. I don't know. That makes him 95 years old, unless he's died since they put this website together. So it says, now that you've learned the basics, let's practice them again using a different guided activity here. So, all right, read the code, try to protect the output. Import our turtle, define main. This time we named our turtle Tina. All right, Tina Turtle. Told Tina to use the color red. All right, grab your red marker, Tina, and go forward 100 pixels. And then we want Tina to turn left 90 degrees and want Tina to go forward another 100 pixels. Turn left again, go forward another 100 pixels, and then turn left, and that's it. So we expect what? 1, 2, 3 lines and 90 degrees. So we got 3/4 of a box, it looks like. Let's see what Tina does. 90, there we go. And she's turned, but after that last turn, we didn't have her do anything. We just said turn left. So you can see the turtle's facing down. Tina drew, turned, drew, turned, drew, turned. And if we add additional forward commands, let's go ahead and have her go, Tina, go forward another 100. Run program. Left, left, left. Now she completes the square just by adding another 100 forward. And we can have her turn again or whatever we need. All right, let's look and see what else they have here. Read the code, try to predict the output. All right, now we have Tori Turtle. We've named our turtle Tori. And we said, Tori, we want you to grab the purple marker. And then we got Trey. We got 2 turtles. We got Tori and Trey, twin turtles. And so, Trey, you grab the blue marker. All right, and now we've designated a size. we just say we're going to set this variable called size, and the size is going to be 100. And so then we've got these little sub modules. So they put comments just so we know. So this is Tory Turtle drawing a triangle. So we told Tory to go forward this size, 100, turn left 120 degrees, go another 100, turn left 120 degrees, go another 100. And then Trey Turtle is going to draw this triangle, go backwards 100, go right 120 degrees, and backwards 100. Let's see what it looks like, because that's not a complete triangle. He's just drawing twice. Run program. So they both start in the exact same place. But since Trey is going backwards, he's backing up and going to the left. Tory went forward to the right, because they always start out at 0, 0, facing to the right, which, if you think about it in math, that's actually at 0 degrees. If you're looking at radians, to the right is 0 degrees. That's where they start. So they're facing 0 degrees. So we want to make Trey move right 120 pixels and backward to complete the triangle, because he's drawing his backwards. So he turned right 120. So let's do another one. Trey, turn right another 120. And then Trey, move backward again. Same size. All right, let's run him again. So Tori drew her triangle, and then Trey drew his triangle. Perfect. So the two turtles mirror each other by moving in opposite directions. All right, let's see what else they want us to do with this. Read the code, predict the output again. All right, so we've got Tia. Now, we've got a lot of turtles. We've obviously got a lot of turtles later on. This one's Tia. Said, Tia, grab the blue crayon. And then Ted, I want you to grab the orange one. So we got Tia and Ted with the blue and the orange. So these turtles are going to move to draw spirals. So we're going to make these size 20. And again, you can just put the 20 in here if you wanted, but you can designate the size out front. So move forward 20, and then left 72, forward 20, left 120. Oh, this is Ted. We got T and Ted. T is going to go forward and left 72. Ted's going to go forward and left 120. And then we're going to add 7 to the size. All right, we're going to add 7 and then do this again. Go forward, 72, go forward, 120. And we're going to add another 7. And we're going to add another 7. And we're going to keep doing that over and over and over. 7, add 7. So let's see what that looks like. We're adding 7 every time to the size. So every time it's 7 pixels longer than when it started. Now notice our orange one, which is in that Ted, grabbed our orange one. Yeah, Ted, he's actually doing triangles here because he's turning 120, which was triangle. But every time he's going longer, so his triangle doesn't ever close. It's just getting bigger and bigger as the farther it continues. Now, since Tia is only turning 72 degrees, she's kind of making a pentagon because 5 of those sides would be a pentagon, except for each side gets longer by 7. So it never completes the pentagon. It's just getting to be a bigger and bigger one. So it begins to form this spiral. So you notice how the commands repeat. So what if the turtles turned to face a different direction before they started to move? It could do that. You could tell way up here at the beginning for Ted, right here at the beginning, we can say Ted equal right. Ted dot right, pardon me. Ted dot right 90 degrees. We could turn Ted sideways at the very beginning. And then when we run that, he went down first. She went to the right, he went down. So it just changes what their starting position is by putting a right 90 degrees in there. All right, last one here. Now it says your turn. Create a turtle and move it in a pattern or shape of your choosing. Maybe an octagon or an outline of a house. refer to previous slides of it. So this is where you can just come in and play. They just give you Terry the turtle, who has picked up a green marker, and they've set you a size of 35. No commands have been given to Terry. If we run it, nothing happens. See, there's Terry with a green marker, but nothing happens because no commands have been given to Terry. So that's just left for you to play. This is a good place for you to get creative and practice this, because next we will be writing a program with this. So this is a good place to get them practice so you know how to do things with your turtle. But that is all of that lesson. The last page, it says read the lesson, practice, and then do the assignment, which the assignment this week is just a multiple choice assignment. Like I said, probably next week that we'll be writing the program. I haven't looked. I don't remember if it's next week or the week after, but Python has a built-in library function. It's called Turtle Graphics. True or false? What does it allow programmers to do? Creating a game. So 5 questions. That's all you got. And 2 of them look to be true or false. So 2 true or false questions. I'll leave. And I think you should have at least 2 or 3 attempts at that. If you do terrible the first time, you have more attempts that you can do on that. So that's it. We'll learn about for loops and while loops and creating functions. So some of these loops will help us when we learn about the for loops next week. That last example they gave where they moved them forward and then added 7 and moved again, and they did all these loops where they kept doing the same command over and over again. When we learn about loops in the next 2 weeks, you don't have to write this command once, and you can put them inside of a loop where it would go through the loop and then go back to the top of the loop and do it again. It just keep repeating for as long as we told the loop to function. So we'll learn about that in future weeks. This week, they just repeated the same commands over and over to accomplish the same thing that you could accomplish with a loop. So get in there on that page 4, play with that. Go through that last Python guided module and see what you can do with the turtle. Have some fun with it. Look at those commands that's in the Google Classroom and play. See if you can make a square and fill it in, and make a circles and just have some fun with it. Get familiar with it, because that's what we'll be using from now until Christmas is the turtle graphics. And anyway, so guys, this week is a B Friday, so we will have class on Wednesday for anyone that needs help with anything. Like I said, this is just a 5-question multiple choice. So if you're behind anything, if you're missing any programs, get them done this week. Get them done by Friday. You really don't want to spend your Thanksgiving break doing schoolwork. Nobody wants to do that. So work hard this week. If you're behind in classes, get everything caught up. Spend a good hard week getting caught up if you're behind, and enjoy your break. And if you're current, get everything done by Wednesday. Have a longer break than everybody else. All right, guys, I will let you go. I'll be here if you need me. Email questions.